Tonight, before sleep slowly settles in, imagine drifting far beyond the familiar planets of our own solar system. Imagine leaving behind the warm light of the sun and gliding quietly into the deeper ocean of the galaxy, a place where thousands of strange worlds circle distant stars. Welcome to Velarin, Sleepy Space Mysteries, a place where the universe becomes a calm story told slowly beneath the stars. If you enjoy peaceful journeys through the cosmos like this one, you might remember another Velarin episode where we explored the quiet mystery of rogue planets drifting between the stars. Those lonely wanderers were only the beginning, because tonight, our journey continues deeper into the strange diversity of planetary worlds. And the truth is, planets are far stranger than most of us ever imagined. Some worlds are so hot that metal can melt into vapor high in their skies. Some planets rain glass sideways through violent alien storms. Others may be made partly of diamond, compressed under unimaginable pressure deep within their interiors. And there are even worlds that drift through space completely alone, never seeing a sunrise. These discoveries might sound like science fiction, but every year, astronomers uncover more of these extraordinary worlds orbiting distant suns. In fact, we now know that planets are everywhere. There may be more planets than stars in the Milky Way galaxy. Trillions of quiet worlds, turning slowly in darkness. So tonight, as your body begins to relax and your thoughts grow softer, we'll explore some of the most fascinating, mysterious, and peaceful facts about planets ever discovered. If you enjoy this gentle journey through space, consider subscribing, leaving a like, and ringing the notification bell so you never miss a new sleepy cosmic story. And before we begin our quiet voyage, tell me in the comments, where in the world are you listening from tonight? Now take a slow breath, and let's drift peacefully into the strange and beautiful worlds beyond our solar system. Somewhere far beyond the quiet orbit of Pluto, far beyond the distant edge of our own solar system, the galaxy is filled with worlds we are only beginning to understand. For thousands of years, humanity looked up at the night sky and imagined that the planets we knew were the only ones that existed. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, 8 quiet companions circling our sun. But the universe had a much bigger story waiting for us. When astronomers finally developed the tools sensitive enough to detect planets around other stars, something remarkable happened. Instead of discovering a few distant planetary systems that looked like our own, they found an astonishing diversity of worlds. Planets that were larger than anything in our solar system, planets smaller than Mercury, planets orbiting 2 suns, and planets drifting through the darkness completely alone. Some of these discoveries feel almost dreamlike, the kind of places that seem too strange to be real. Yet every one of them reminds us that nature is far more creative than our imaginations. One of the most extraordinary examples is a planet known as KLT 9b. This world orbits its star so closely that its year lasts barely more than a single Earth day. The star above it burns with an intense blue light, far hotter than our sun, and the planet sits so close that its atmosphere is heated to temperatures hotter than many stars themselves. Imagine standing on such a world, though of course no solid ground exists there. Instead, endless layers of glowing gas churn under impossible heat. Temperatures rise high enough that molecules cannot remain intact. Atoms are ripped apart, metals vaporize, and the entire atmosphere begins to escape into space. From a distance, this escaping gas stretches behind the planet like a faint glowing tail, almost like a comet trailing light as it moves through the darkness. Worlds like this are often called ultra-hot Jupiters, giant planets that orbit extremely close to their stars. Their existence surprised astronomers when they were first discovered, because traditional theories suggested gas giants should form much farther away where temperatures are cooler. Yet the galaxy clearly enjoys breaking expectations. Somehow these enormous planets formed elsewhere and slowly migrated inward, pulled closer to their stars through long gravitational interactions. Over millions of years they drifted inward until they reached their current orbits, where stellar radiation now sculpts their atmospheres into something fragile and temporary. And this leads to one of the quiet mysteries we will revisit throughout our journey tonight. How many planets live brief, dramatic lives like this before disappearing entirely? Some of these worlds may slowly lose their atmospheres until only a rocky core remains. Others may eventually spiral inward and fall into their stars, vanishing in a final burst of light. But before that happens, they circle their suns again and again, glowing like distant embers in the cosmic night. Not all strange planets are burning infernos, though. Some are built from materials so unusual that they challenge how we imagine geology itself. Consider a planet where carbon dominates the chemistry of its formation. Deep inside such a world, enormous pressure could compress carbon atoms into crystalline structures. Over immense timescales, entire layers of the planet's interior might slowly transform into diamond. Imagine mountains formed not of granite or basalt but of compressed carbon crystals buried under crushing weight. It would not be a sparkling jewel the way we picture diamonds on Earth. Instead, it would be dark, silent, and unimaginably dense, hidden deep beneath the surface of a distant world. These diamond-rich planets may sound exotic, yet the physics behind them is surprisingly straightforward. If a young star contains more carbon than oxygen in the surrounding protoplanetary disk, the materials available during planet formation change dramatically. Silicon and oxygen may be less common, while carbon compounds become dominant. Over time, gravity gathers these materials into growing worlds, and pressure does the rest. The deeper you travel into such a planet, the greater the pressure becomes, until ordinary carbon rearranges itself into crystalline forms stronger than any rock. Somewhere in the galaxy there may be entire planets whose interiors contain more diamond than exists on Earth's entire surface. The thought alone is enough to make the imagination drift quietly through the possibilities. And yet even that is only the beginning of how strange planets can be. Because some of the most beautiful planetary skies may belong to worlds that orbit not one star, but two. Now imagine a sky that never shows just one sunrise. Instead, two stars slowly climb above the horizon, their light blending together across alien clouds. Shadows stretch in different directions, and the landscape glows with a strange double brightness. For a long time, this kind of world existed only in stories and science fiction, but astronomy has quietly confirmed that such planets truly exist. They are known as circumbinary planets, worlds that orbit around two stars instead of one. In these systems, the stars themselves circle each other in a slow gravitational dance, and the planet travels around both of them together, tracing a much larger orbit. To anyone standing on such a world, the sky would feel wonderfully unusual. Some days one sun might rise first while the other lingers below the horizon. On other days, both stars might climb together, glowing like twin lanterns suspended in space. When evening arrives, the sunsets could be staggered, one star dipping away before the other slowly follows, leaving behind a long twilight that stretches across the sky. These strange rhythms are not just beautiful but also delicate. The gravitational balance in a two-star system is complicated, and a planet must follow a very stable path if it hopes to remain there for millions or billions of years. If the orbit becomes too close to the stars, their combined gravity could pull the planet into chaos. If it drifts too far away, the bond might weaken and the planet could escape entirely. Yet many of these systems have survived for astonishing lengths of time, proving that planetary stability can exist even in environments far more complex than our own solar system. Some of the earliest confirmed examples of circumbinary planets surprised astronomers because they behaved so predictably. Their orbits were stable, their paths smooth and regular, as though the planet had learned to move perfectly in step with the gravitational rhythm of its two suns. It is almost like watching a carefully choreographed dance, where each body moves with quiet precision, never colliding, never drifting apart. But even more mysterious are the planets whose skies are dominated by extreme weather beyond anything we know on Earth. One such world is famous for its astonishing storms of molten glass. This planet is a gas giant that orbits extremely close to its star, completing a full orbit in just over 2 Earth days. The star's intense heat raises the temperature of the planet's atmosphere to nearly 2,000 degrees Fahrenheit. At those temperatures, tiny particles of silicate minerals rise into the atmosphere like dust carried upward by heat. These minerals are the same materials that make up glass here on Earth. High above the planet, powerful winds sweep these particles through the atmosphere at speeds that may reach several thousand miles per hour. Eventually, the minerals begin to condense into droplets, and something extraordinary happens. Instead of water, rain, or ice crystals, molten glass begins to fall from the clouds. Because the winds are so powerful, this rain does not fall straight downward. Instead, it is blasted sideways across the planet's atmosphere, streaking across the sky like a storm of glowing shards. From far away, the planet actually appears a calm and beautiful shade of blue, almost peaceful when viewed through a telescope. But beneath that distant glow lies an environment of unimaginable violence, where glass storms sweep through the atmosphere endlessly. And yet, the universe also creates planets that are the opposite of fiery chaos. Some worlds are dominated almost entirely by water. Imagine a planet where there are no continents at all, no rocky shorelines or mountains rising above the sea. Instead, the entire surface is covered by a global ocean that stretches uninterrupted across the planet. These so-called ocean worlds may contain water layers hundreds or even thousands of miles deep. At the surface, waves might move gently under a dim sun, but far below, the pressure increases steadily until water begins to behave in unfamiliar ways. Under extreme pressure, water can freeze into exotic forms of ice that are far denser than the ice we know. These high-pressure ices do not float like frozen water on Earth. Instead, they sink and form thick crystalline layers deep beneath the ocean. Somewhere below those layers there may still be a rocky core slowly releasing heat left over from the planet's formation. This internal warmth could create hidden liquid layers trapped beneath miles of high-pressure ice, forming vast unseen seas sealed away from the surface forever. Whether life could exist in such strange oceans remains one of the great unanswered questions of planetary science. But the possibility is difficult to ignore. After all, life on Earth began in water, and our own oceans hide ecosystems that thrive in complete darkness around deep-sea volcanic vents. If life can survive there, perhaps somewhere in the galaxy an ocean world drifts quietly through space with living oceans stretching endlessly beneath its clouds. And if that possibility exists, it leads us to another strange planetary condition that appears again and again among distant worlds. Planets that show only one face to their star forever. Among the many strange worlds astronomers have discovered, some planets exist in a condition that feels almost frozen in time. These planets are known as tidally locked worlds. On Earth, our planet spins continuously, giving us a cycle of sunrise and sunset every 24 hours. But tidal locking changes that rhythm completely. When a planet becomes tidally locked to its star, one side of the planet always faces the star, while the other side remains in permanent darkness. The same hemisphere receives endless daylight, while the opposite hemisphere never sees the star at all. Our own moon shows us a small example of this phenomenon. The moon rotates in such a way that we always see the same side from Earth, while the far side remains hidden from view. But imagine this effect on the scale of an entire planet. On the day side, the star would hang motionless in the sky, never rising and never setting. The landscape beneath it would experience continuous daylight. Depending on the planet's distance from the star, this could create regions of extreme heat where temperatures remain permanently high. Oceans might slowly evaporate, clouds might gather endlessly in towering formations, and powerful atmospheric currents could push heat outward across the planet. Meanwhile, the night side would exist in eternal darkness. Without sunlight, temperatures there could drop dramatically. Ice might form across enormous regions, and the sky would always be filled with stars, unchanging and quiet above a frozen landscape. Between these two extremes lies one of the most intriguing environments imaginable. Along the boundary where the dayside and nightside meet, there may exist a narrow ring around the planet called the Terminator Zone. Here the star would sit forever on the horizon, casting a soft orange glow across the land. It would never fully rise, yet it would never completely disappear. The temperature in this twilight region might be far more moderate than on either side of the planet. Some scientists have wondered whether such zones could potentially support life under the right conditions. In this narrow band of permanent dawn, Winds might move steadily as warm air from the dayside flows toward the colder night side. Clouds could form and dissolve in slow cycles, and the climate might remain relatively stable for long periods of time. It is a fascinating possibility, a world where life survives only within a thin ring that circles the planet endlessly, always balanced between scorching daylight and frozen night. Tidally locked planets appear to be quite common around small stars, particularly around red dwarfs, which are the most abundant type of star in our galaxy. Because red dwarfs emit less light and heat than stars like our Sun, their habitable zones are much closer in. Any planet orbiting within that zone is often pulled into tidal locking over long timescales. If life ever arises on such a world, it would experience a very different sense of time. There would be no daily cycle of morning and evening. Instead, the sky would remain unchanged, a constant horizon where light and shadow meet. But tidal locking is not the only way planets experience extreme environments. Some planets orbit so close to their stars that their very atmospheres begin to escape into space. These worlds are often massive gas giants known as hot Jupiters. When such a planet drifts extremely close to its star, intense radiation heats its upper atmosphere until the gases expand outward. Eventually, some of those particles gain enough energy to escape the planet's gravity entirely. Over time, this process can create enormous streams of gas trailing behind the planet like a glowing tail. Through powerful telescopes, astronomers have detected these escaping atmospheres as faint clouds of hydrogen and helium drifting into space. In certain cases, the escaping gas stretches tens of thousands of miles away from the planet, forming a long comet-like structure illuminated by the star's light. This means that some planets may slowly shrink over time as their atmospheres are gradually stripped away. A giant world that once resembled Jupiter could eventually be reduced to a much smaller remnant after millions or billions of years of constant erosion. Watching this process unfold gives astronomers a rare glimpse into the long life cycles of planets. Worlds are not permanent objects that remain unchanged forever. Just like stars, they evolve, transform, and sometimes fade away. And yet, even as some planets are slowly being worn down by their stars, others exist in the opposite extreme of darkness, drifting through space without any star at all. Out in the vast darkness between the stars, there are worlds that no longer belong to any sun. These are known as rogue planets, and they may be among the loneliest objects in the entire galaxy. Most planets form within swirling disks of gas and dust around young stars. Gravity slowly gathers material together, building larger and larger bodies until planets are born. In a stable system, those planets remain in orbit around their star for billions of years. But the early life of a planetary system is often chaotic. Giant planets migrate, gravitational encounters occur, and sometimes the delicate balance of orbits is disturbed. When this happens, a planet can be thrown outward with enough speed to escape its star completely. Instead of circling a sun, it begins a silent journey through interstellar space. These rogue planets drift through the galaxy alone, traveling through darkness that stretches for trillions of miles. Without a nearby star, their skies would appear profoundly different from ours. There would be no sunrise, no sunset, and no warm glow of daylight spreading across the horizon. Instead, the sky would remain permanently black, filled with distant stars that never change position in the sky. The surface of such a world would likely be extremely cold. Temperatures could drop hundreds of degrees below freezing, turning oceans into thick shells of ice and leaving landscapes buried beneath endless frost. Yet even in such darkness, some rogue planets might still hold hidden warmth. Deep inside a planet, radioactive elements slowly release heat as they decay. This internal heat can remain trapped for billions of years within the planet's interior. If the planet once possessed large oceans before it was ejected from its original star system, those oceans might freeze at the surface but remain liquid far below the ice. Beneath miles of frozen crust, a dark ocean could continue to exist, warmed from below by geothermal heat. In that hidden ocean there would be no sunlight, only darkness and the faint warmth rising from the planet's core. But life on Earth has shown that sunlight is not always necessary for survival. In the deepest parts of our oceans, near hydrothermal vents on the seafloor, entire ecosystems exist without any sunlight at all. Microorganisms there survive by using chemical energy released from the Earth's interior. Some scientists wonder whether a similar process might occur inside rogue planets. If so, these lonely wanderers drifting between the stars could potentially harbor small ecosystems hidden beneath thick shells of ice. It is a quiet and haunting idea. Life existing in total darkness on a planet with no sun, traveling silently through the galaxy for billions of years. Rogue planets may actually be far more common than we once believed. Some studies suggest that there could be billions of them scattered throughout the Milky Way. Detecting them is difficult because they do not shine with reflected starlight the way ordinary planets do. Instead, astronomers often find them through a phenomenon called gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity briefly bends and magnifies the star's light. For a short time, the star appears brighter before returning to normal. By studying these brief flashes of light, astronomers can infer the presence of otherwise invisible planets drifting through space. It is a delicate method, almost like noticing the ripple of water caused by something unseen moving beneath the surface. But through careful observation, astronomers have begun to reveal a hidden population of wandering worlds scattered across the galaxy. Some of these rogue planets may be small rocky worlds. Others could be gas giants as large as Jupiter. A few might even carry faint atmospheres warmed by residual heat from their formation. Each one represents a planet that once belonged to a star but was cast out during the chaotic early history of its system. And while some planets are lost to the darkness of interstellar space, others experience a very different fate. Instead of drifting away, they circle their stars so closely that they exist in permanent extremes of heat and darkness, forming some of the strangest environments we have ever discovered. As astronomers continued discovering more and more distant worlds, one thing quickly became clear. Planets are not limited to a single familiar pattern. Our solar system once seemed like the template for how planetary systems should look. small rocky planets near the star, giant gas planets farther away, and stable orbits that last for billions of years. But the galaxy has shown us something very different. In reality, planetary systems come in an astonishing variety of forms. Some stars host planets that move with incredible speed, completing an entire orbit in just a few hours. One remarkable example is a rocky world slightly larger than Earth that circles its star once every 8.5 hours. Imagine living on a planet where a full year passes before a single day finishes. The star above such a world would appear enormous in the sky, hanging so close that it would dominate the horizon like a blazing wall of light. The heat from that nearby star would likely melt the surface into vast oceans of lava. Rivers of molten rock could flow slowly across the landscape, glowing dimly against the permanent brightness of the sky. The planet itself might be tidally locked as well, meaning one side constantly faces the star while the other remains locked in darkness. In such an environment, the boundary between day and night might form a narrow region where temperatures are slightly less extreme, a thin twilight strip circling the planet endlessly. Yet while some planets race around their stars at incredible speeds, others move with breathtaking patience. There are worlds whose orbits stretch so far from their stars that a single year there can last centuries. One distant gas giant discovered by astronomers takes roughly 1,000 Earth years to complete one full orbit around its star. For most of human history, that planet has not even completed a small fraction of its current year. Seasons on such a world, if they exist at all, could last for generations. Entire civilizations on a nearby moon might rise and fall before the planet ever returns to the same position in its orbit. Detecting planets with such enormous orbits is extremely difficult. Astronomers cannot simply wait hundreds or thousands of years to watch them complete a full revolution. Instead, they observe subtle movements over time, tiny arcs of motion that slowly reveal the presence of a distant planet traveling along a very long path. These discoveries remind us that planetary time can operate on scales far beyond our daily experience. Some worlds spin rapidly through short orbits, while others drift slowly through centuries of silent motion. And beyond these differences in orbital time, planets themselves can vary dramatically in brightness. Not every world reflects starlight the way Earth does. Some planets are astonishingly dark, absorbing nearly all the light that falls upon them. One such planet discovered by astronomers reflects less than 1% of the light from its star. Its atmosphere contains unusual chemical compounds that absorb starlight instead of scattering it back into space. From a distance, this planet appears almost invisible, like a shadow moving quietly through the glare of its star. If you could somehow observe it up close, the planet might appear darker than charcoal, darker even than fresh asphalt under a night sky. Its atmosphere glows faintly with heat rather than reflected light, giving the world an eerie dim radiance instead of a bright reflection. In contrast, other planets shine with unusual colors created by exotic clouds high in their atmospheres. Some of the hottest gas giants may form clouds made not of water vapor but of vaporized minerals. Aluminum oxide, iron, and other metallic compounds can rise into the upper atmosphere where temperatures are high enough to keep them suspended as gases. As the air cools slightly, These materials begin to condense into tiny particles that form clouds unlike anything seen on Earth. In certain cases, these clouds may contain corundum, the mineral that forms rubies and sapphires. High above the swirling atmosphere of such planets, winds may push these mineral clouds across the sky, tinting the world in shades of red, purple, or deep blue depending on the materials present. It is a beautiful thought. Clouds made from the same minerals we treasure as gemstones quietly drifting through alien skies. And yet, even with all these strange discoveries, astronomers believe we have only begun to understand the true diversity of planetary worlds scattered throughout the galaxy. Every new telescope reveals another surprise waiting in the darkness beyond our solar system. By now, as our quiet journey continues deeper into the universe of distant worlds, something gentle but profound begins to emerge. The idea that planets are not rare objects scattered occasionally across the galaxy. Instead, they seem to be everywhere. For most of human history, we believed our solar system might be unusual, perhaps even unique. The Sun, with its orderly family of planets, seemed like the natural design of a planetary system. But once astronomers began detecting planets around other stars in the early 1990s, that comforting assumption slowly dissolved. One discovery followed another, and then another, until a new realization quietly formed. The Milky Way galaxy may contain hundreds of billions of planets. Some estimates suggest that planets may actually outnumber stars themselves. Every point of light you see in the night sky could host its own collection of worlds silently orbiting in the darkness. Some systems may resemble our own, with rocky inner planets and distant gas giants. Others may look completely unfamiliar, with planets packed tightly around their stars like beads on a string. The diversity is staggering, and with each new discovery, astronomers gain a deeper appreciation for how flexible planet formation can be. One of the most powerful tools scientists use to find these distant worlds is something surprisingly simple: shadows. When a planet passes in front of its star from our point of view, it blocks a tiny fraction of the starlight. The star briefly dims, sometimes by less than 1%, before returning to its normal brightness. This subtle event is known as a transit. To the naked eye, such a change would be impossible to notice, but space telescopes are incredibly sensitive instruments capable of measuring tiny variations in brightness. Missions like Kepler spent years staring at thousands of stars at once, watching patiently for these faint dips of light. Each small flicker could signal the presence of a planet crossing its star. By carefully measuring the depth and timing of these dips, astronomers can learn a remarkable amount about the unseen world responsible. The size of the planet can be estimated from how much light it blocks. The length of time between each transit reveals the planet's orbital period. Even the atmosphere of the planet can sometimes be studied, because a small portion of the starlight filters through the planet's atmosphere as it passes by. Within that filtered light lie subtle signatures of molecules drifting in alien skies. Water vapor, methane, carbon dioxide, and other gases leave faint fingerprints in the spectrum of starlight. By reading those fingerprints, scientists can begin to piece together the composition of atmospheres on worlds dozens or even hundreds of light years away. It is an astonishing achievement when you think about it. Without ever leaving our own planet, we are learning about the chemistry of skies that belong to distant worlds orbiting other suns. Another powerful method for detecting planets relies not on shadows, but on gravity. Planets do not simply orbit their stars while the stars remain perfectly still. In reality, both the planet and the star orbit a shared center of mass. Because the star is so massive, its movement is extremely small, but it is still there. As the planet circles its star, the star itself wobbles ever so slightly. This wobble changes the color of the star's light in a tiny but measurable way. When the star moves slightly toward Earth, its light shifts toward the blue end of the spectrum. When it moves slightly away, the light shifts toward red. By measuring these changes with extremely precise instruments, astronomers can detect the gravitational tug of an unseen planet. This technique, called the radial velocity method, was responsible for the discovery of some of the very first exoplanets ever confirmed. It is a reminder that even distant planets leave subtle fingerprints in the behavior of their stars. We may not see the planet directly, but we can observe the dance it performs with its star across the vastness of space. Together, these methods have opened a new window onto the galaxy, revealing planetary systems of breathtaking complexity and variety. Yet, as powerful as our telescopes have become, we are still only glimpsing the outer edges of these distant worlds. We cannot yet stand on their surfaces, feel their winds, or walk beneath their skies. For now, we remain quiet observers, reading the faint messages written in starlight and shadows. As telescopes have grown more powerful, astronomers have begun to notice that planets do not always exist in simple systems with only one or two companions. In fact, many stars appear to host entire families of worlds orbiting together in complex arrangements. Some of the most fascinating systems discovered so far contain multiple rocky planets packed closely around small stars, each moving in carefully balanced orbits. In a few remarkable cases, these planets move in what astronomers call orbital resonance. This means their orbital periods form simple ratios with one another. For example, one planet might complete 2 orbits around its star for every 3 orbits made by its neighbor. Another might complete 3 orbits in the same time another completes 4. These patterns are not accidents. They are the result of long gravitational interactions that slowly guide planets into stable rhythms over millions of years. When planets settle into these resonant patterns, they create something that resembles a quiet cosmic clockwork. Each planet follows its own path, yet their motions remain linked together through gravity. It is almost like listening to a piece of music where different notes repeat in a harmonious pattern, each one perfectly timed with the others. Systems like these can remain stable for billions of years, their planets circling endlessly in synchronized motion. If you could stand on one of those worlds and look up into the sky, you might sometimes see neighboring planets appearing as bright disks rather than tiny points of light. Because the planets orbit relatively close to one another, they could appear much larger than the planets we see from Earth. Instead of small dots drifting slowly across the sky, they might look like glowing spheres hanging silently in the darkness. But not every planetary system is so carefully balanced. Some appear to exist in far more chaotic arrangements where gravitational forces constantly reshape the paths of the planets involved. In these systems, giant planets may wander inward toward their stars, pushing smaller planets aside or ejecting them completely. Others may tilt the orbits of neighboring worlds until the entire system becomes unstable over time. Astronomers can simulate these gravitational interactions using powerful computer models. And sometimes those simulations reveal a dramatic future for certain planetary systems. A system that appears stable today might eventually experience collisions between planets or the ejection of worlds into interstellar space millions of years from now. From our perspective here on Earth, those timescales feel unimaginably long. Yet, on the scale of cosmic history, planetary systems are dynamic places that continue evolving long after they first form. Even our own solar system has experienced periods of dramatic change. In the distant past, the giant planets may have migrated through different positions before settling into the orbits we see today. These migrations could have scattered smaller bodies across the solar system, contributing to the asteroid belts and comet populations we observe now. When we study distant planetary systems, we are essentially looking at different chapters of that same story unfolding elsewhere in the galaxy. Some systems are still young and chaotic, while others have settled into stable arrangements that may last for billions of years. And within these diverse systems, astronomers have also discovered planets orbiting some of the most unusual stars imaginable. One surprising example involves planets orbiting the remnants of dead stars. When a star like our Sun reaches the end of its life, it eventually sheds its outer layers and leaves behind a small, dense core known as a white dwarf. These stellar remnants are incredibly compact, packing a large amount of mass into a body roughly the size of Earth. For a long time, scientists assumed that the violent processes involved in a star's death would destroy any nearby planets. Yet, observations have revealed that some planets may survive this dramatic transformation. Others may even form afterward from the leftover debris surrounding the white dwarf. A planet orbiting such a stellar remnant would experience a very different sky than the one we know. The star would appear small and intensely bright, glowing like a hot ember in space. Over billions of years, the white dwarf would gradually cool and fade, leaving the planet orbiting an ever-dimming source of light. It is a haunting image, a quiet world circling the remains of a once brilliant star, continuing its orbit long after the original star's life has ended. These discoveries remind us that planets are remarkably resilient objects. They can form in many different environments, survive dramatic cosmic events, and persist long after the stars that created them have changed forever. As the catalog of discovered planets continued to grow, astronomers began noticing something else that was quietly surprising. Not every planet fits neatly into the categories we once used to describe worlds. For many years, scientists assumed planets would fall into two broad groups: small rocky planets like Earth, or large gas giants like Jupiter and Saturn. But the galaxy has introduced us to many worlds that exist somewhere between these familiar types. One of the most common examples is a category known as the super-Earth. Despite the name, these planets are not necessarily similar to our own world. The term simply describes planets that are larger than Earth but smaller than Neptune. Some super-Earths may be rocky with thick atmospheres, while others may hold deep oceans or dense layers of exotic ice beneath their surfaces. Their gravity is usually stronger than Earth's, which means their atmospheres can become thicker and more stable over time. In some ways, such conditions could even create environments that are more stable than our own planet's climate. A slightly stronger gravity could help a planet retain its atmosphere for billions of years, protecting it from being stripped away by stellar winds. A thicker atmosphere might also distribute heat more evenly across the planet's surface. These possibilities have led some scientists to wonder whether certain super-Earths might actually be better suited for life than Earth itself. Of course, we still know very little about the surfaces of these distant worlds. From our vantage point across light years of space, we can only measure their mass, size, and orbital distance. But even those basic details hint at an incredible diversity of planetary environments waiting to be understood. Another class of planets that surprised astronomers is known as the mini-Neptune. These planets are larger than Earth but surrounded by thick envelopes of hydrogen and helium gas. Unlike rocky planets, mini-Neptunes may not have a clearly defined surface at all. Instead, their outer layers gradually transition from gas to dense fluid and eventually to a rocky or icy core deep inside. If you could somehow descend through the atmosphere of such a planet, you would pass through enormous layers of cloud and gas before reaching regions where pressure becomes so intense that the atmosphere behaves almost like an ocean of compressed fluid. These strange intermediate worlds appear to be extremely common throughout the galaxy. In fact, many astronomers now suspect that mini-Neptunes may represent one of the most abundant types of planet in the Milky Way. Their existence reminds us that our solar system may not represent the most typical planetary arrangement. The worlds we see around us might simply be one variation among countless possibilities. Some exoplanets are even more unusual because they seem to be almost impossibly lightweight. These planets, sometimes called puffy planets, are gas giants that have expanded to enormous sizes while containing relatively little mass. Their atmospheres are so inflated that their overall density becomes extremely low. In theory, if you could place one of these planets into an ocean large enough to contain it, the planet might actually float. The reason for their swollen size likely comes from the intense heat of nearby stars. When a gas giant orbits very close to its star, the star's radiation can heat the planet's atmosphere until it expands dramatically. The outer layers of gas stretch outward, becoming less dense while still remaining gravitationally bound to the planet. The result is a huge world that appears almost delicate despite its massive scale. But planets can also exist at the opposite extreme of density. Some rocky worlds discovered by astronomers appear to be incredibly compact. These planets may contain large metallic cores composed mostly of iron and other heavy elements. Under the immense pressures deep inside such planets, familiar materials behave in unfamiliar ways. Metals may compress into exotic forms while gravity squeezes the entire planet into a smaller radius than expected for its mass. Standing on the surface of one of these dense planets would feel very different from standing on Earth. Gravity might be much stronger, pulling firmly on everything around you. Mountains might be shorter and flatter because rock cannot support tall structures under intense gravitational pressure. Even the atmosphere might behave differently under such conditions. These examples reveal a quiet truth that continues to reshape astronomy. Planets are not simple objects following a single pattern. They are endlessly varied creations shaped by the chemistry, gravity, and history of their star systems. And with every new discovery, the universe reminds us that the possibilities for planetary worlds are far broader than we once imagined. As astronomers looked deeper into the galaxy, they also began noticing that some planets exist in environments that seem almost impossible at first glance. These worlds orbit stars that behave very differently from our Sun. Some circle tiny red dwarf stars, the most common type of star in the Milky Way. Red dwarfs are smaller, cooler, and far dimmer than our Sun, glowing with a soft reddish light. Because they produce less energy, their habitable zones, the regions where liquid water could exist, lie much closer to the star. Planets that orbit within these narrow zones must travel very near their stars to receive enough warmth. This closeness often leads to tidal locking, the condition we explored earlier where one side of the planet permanently faces the star. But red dwarf systems introduce another layer of mystery. Many young red dwarfs are extremely active stars that release powerful stellar flares. These bursts of radiation can be thousands of times stronger than the largest solar flares our Sun produces. A nearby planet might experience repeated blasts of high-energy radiation sweeping across its atmosphere. If such a planet has a strong magnetic field, that field might shield the surface by deflecting charged particles. Without that protection, however, the planet's atmosphere could gradually be stripped away by the relentless stellar wind. Over millions of years, a once thick atmosphere might slowly erode, leaving the planet exposed and barren. Yet not all red dwarfs are violent. Some are remarkably calm, glowing steadily for trillions of years. These quiet stars burn their fuel so slowly that their lifetimes extend far beyond the age of the universe as it currently exists. Around these stable red dwarfs, planets may enjoy extremely long periods of gentle, consistent starlight. A planet orbiting such a star could potentially remain habitable for vast stretches of time, far longer than Earth is expected to remain comfortable for life. Imagine a civilization evolving beneath a dim ruby-colored sun that barely changes brightness for billions upon billions of years. The sky would glow with a warm crimson hue, and the slow rhythm of the star would give life on that world unimaginable stretches of stability. But red dwarfs are not the only unusual stellar environments where planets can exist. Astronomers have also discovered planets orbiting neutron stars, the collapsed cores of massive stars that exploded long ago in supernova events. A neutron star is an object of astonishing density. It compresses more mass than our Sun into a sphere only about 20 kilometers across. The gravity near its surface is so strong that atoms themselves behave differently under the immense pressure. Many neutron stars spin rapidly, rotating dozens or even hundreds of times every second. As they spin, they emit beams of radiation that sweep across space like cosmic lighthouses. When these beams point toward Earth, we observe regular pulses of radio waves. Such objects are known as pulsars. For a long time, astronomers assumed that the violent explosion that forms a neutron star would destroy any planets nearby. Yet the very first confirmed exoplanets ever discovered were found orbiting a pulsar. These planets circle a stellar remnant that once detonated with unimaginable energy. Their origins remain mysterious. Some may have survived the explosion of their parent star, somehow enduring the blast and settling into new orbits afterward. Others may have formed later from disks of debris created by the supernova itself. Either way, the idea of planets orbiting such an extreme object stretches our imagination. The sky above one of these worlds would be unlike anything we experience. Instead of a steady glowing sun, the sky might contain a small but incredibly bright star that flashes rapidly with beams of radiation as it spins. The environment would likely be harsh and filled with energetic particles streaming through space. Yet the existence of these planets demonstrates something remarkable about the universe. Planet formation is not limited to calm and gentle conditions. Even after a star explodes and leaves behind a dense stellar corpse, gravity and leftover material can still assemble new worlds. This resilience of planet formation suggests that planets may arise in many environments we once believed impossible. From quiet red dwarf systems to the aftermath of stellar explosions, the galaxy continues to reveal places where worlds persist. And perhaps the most surprising realization of all is that we are still only at the beginning of discovering these distant planets. With each new generation of telescopes, the number of known worlds continues to grow, and with them our sense of how vast and varied the universe truly is. As we continue drifting through these quiet discoveries, another gentle realization begins to settle in. The story of planets is not only about how they form, but also about how they change over time. Just like stars, planets experience long life cycles shaped by gravity, radiation, and the slow passage of billions of years. Some planets remain stable for enormous stretches of time, circling their stars in calm, predictable paths. Others slowly evolve, losing their atmospheres, changing their climates, or drifting into new orbits. In some cases, planets may even be destroyed entirely. One of the most dramatic ways this can happen is when a planet slowly spirals inward toward its star. When a planet orbits extremely close to its star, tidal forces begin to affect its motion. Gravity from the star pulls strongly on the planet, stretching it slightly and generating internal friction within the planet's interior. Over very long periods of time, this interaction can cause the planet's orbit to shrink little by little. The change is incredibly slow, sometimes only fractions of a second difference in the planet's orbital period each year. But over millions of years, those tiny changes add up. Eventually, the planet drifts closer and closer to the star until the final outcome becomes unavoidable. At the end of this gradual descent, the planet may cross a critical boundary where the star's gravity overwhelms it completely. When that moment arrives, the planet can be torn apart by tidal forces or plunge directly into the star itself. Astronomers have observed hints of this process in several distant systems where planets appear to be slowly losing altitude in their orbits. These are worlds living their final chapters, circling their stars as gravity quietly pulls them toward a distant but inevitable fate. But destruction is not always the end of the story for planets. Sometimes the materials left behind after cosmic events become the building blocks for new worlds. In young star systems, planets often collide with one another during the chaotic early stages of formation. These collisions can shatter entire worlds, scattering enormous clouds of debris into orbit around the star. Over time, gravity gathers this debris together again, forming new planetary bodies from the remnants of earlier ones. Even in mature systems, collisions between large objects can reshape the architecture of planetary systems. Our own moon is thought to have formed when a Mars-sized object collided with the early Earth billions of years ago. The impact ejected huge amounts of molten rock into orbit, which eventually gathered together to form the moon we see today. Similar processes may occur in many planetary systems across the galaxy. Some exoplanets we observe today could be the rebuilt fragments of older worlds that were once destroyed in ancient collisions. In this way, the history of a planetary system may contain many generations of worlds forming, breaking apart, and forming again. This cycle of creation and destruction is a natural part of cosmic evolution. It reminds us that planets are not static objects frozen in time. They are dynamic participants in the ongoing story of their star systems. Yet even as planets experience these dramatic changes, some systems achieve remarkable stability. Certain planetary arrangements remain balanced for billions of years, with multiple worlds orbiting peacefully in resonant patterns. These systems resemble delicate cosmic machines where gravity keeps every planet moving in perfect rhythm. Observing such systems gives astronomers valuable clues about how planets migrate and settle into long-term stability. Each system we discover offers another piece of the puzzle, helping us understand how the countless worlds of the galaxy come to exist. And through all of these discoveries, one quiet truth continues to emerge. The universe does not create planets in only one way. Instead, it seems to experiment endlessly with new possibilities. Some worlds burn beneath blazing stars, others drift through interstellar darkness, and many more exist in environments we are only beginning to imagine. As our telescopes grow more powerful and our understanding deepens, the number of known planets continues to rise. With each new discovery, we are reminded that our own solar system is only one small example among a vast ocean of planetary systems scattered across the Milky Way. Somewhere out there, countless worlds continue their silent journeys through space, each one carrying its own unique history written in gravity, light, and time. As our quiet journey through the universe of planets continues, it is worth pausing for a moment to appreciate how much our understanding of these distant worlds has changed in such a short time. Only a few decades ago, humanity knew of just one planetary system with certainty: our own. The planets of the solar system were familiar companions in the night sky, studied carefully for centuries. Yet beyond them, the galaxy remained a mystery. We could see the stars, but the worlds that might orbit them were hidden from view. Today, that picture has transformed completely. Thousands of planets have already been discovered around distant stars, and astronomers expect that number to grow into the tens of thousands in the coming years. Each discovery adds another small piece to a much larger cosmic puzzle. Some of these worlds resemble the planets we know, while others challenge our expectations in surprising ways. There are planets hotter than lava fields, planets colder than any place in our solar system, and planets that circle stars in arrangements that once seemed impossible. But beyond the scientific details, there is also something deeply calming about the realization that planets are everywhere. The night sky is no longer just a collection of distant stars. It is a vast landscape of hidden worlds quietly orbiting in the darkness. Each star may host its own family of planets, each with its own skies, landscapes, and long histories shaped by gravity and time. When you look up at the sky on a clear night, you are not just seeing points of light scattered across space. You are seeing distant suns that may be surrounded by entire systems of worlds slowly turning in silence. Some of those worlds may be gas giants wrapped in thick layers of cloud. Others might be rocky planets with mountains and valleys shaped by ancient geological forces. A few could even possess oceans or atmospheres that resemble our own in subtle ways. Of course, most of these planets are far beyond the reach of human travel, separated from us by distances so enormous that even light takes years to cross them. Yet, through careful observation and patient study, we have found ways to learn about them anyway. We read the faint dips in starlight that reveal a planet passing in front of its star. We measure the gentle wobble of stars pulled by the gravity of unseen companions. And with each new technique, our picture of the galaxy becomes richer and more detailed. In the coming decades, new space telescopes will continue this exploration. Instruments more sensitive than any we have used before will study the atmospheres of distant planets in greater detail. They may detect traces of water vapor, methane, or oxygen in alien skies. These discoveries will not only deepen our understanding of planets, but also help answer one of the oldest questions humanity has ever asked: whether life might exist somewhere beyond Earth. Even if that question takes many more years to answer, the journey of discovery itself is already remarkable. The universe has revealed that planets are not rare curiosities. They are natural outcomes of the same cosmic processes that formed our own world. Dust gathers, gravity pulls material together, and over time entire worlds emerge from swirling clouds of gas and rock. This process has been unfolding across the galaxy for billions of years. Long before Earth formed, other planets were already circling their stars. And long after our own planet has changed beyond recognition, countless other worlds will still be quietly orbiting distant suns. There is something peaceful about that thought. The universe is vast, patient, and full of slow, steady motion. Planets turn in their orbits without hurry, following paths shaped by gravity and time. And as we continue to study them, we are slowly learning to read the quiet stories written across the stars. As the night grows quieter and your thoughts begin to slow, it can be comforting to remember just how gentle the motion of the universe really is. The planets we have been exploring tonight may sound dramatic in description. Worlds of fire, glass storms, diamond interiors, and frozen oceans. But the way they move through space is almost always calm and patient. Every planet follows a path shaped by gravity, circling its star again and again with quiet precision. Some complete their journeys quickly, racing around their stars in just a few hours. Others take centuries to finish a single orbit. But whether fast or slow, their motion continues steadily year after year, age after age. If you could somehow watch one of these distant systems from far away, the movement would appear almost peaceful. The star would glow steadily at the center, and the planets would drift around it like silent companions tracing invisible circles through the dark. Over time, clouds might gather in alien atmospheres. Winds might shape unfamiliar landscapes. Ice might grow or retreat with long planetary seasons. Yet from the perspective of the cosmos, these changes unfold slowly and quietly, like waves moving across an endless ocean. In many ways, planets are storytellers of time. Their surfaces record ancient impacts from wandering asteroids. Their atmospheres evolve as stars brighten or fade. Their orbits shift gradually as gravity reshapes the architecture of their systems. A rocky world that appears calm today may carry scars from violent events that occurred billions of years ago. Another planet might still be forming, gathering material from the leftover disk of gas and dust surrounding a young star. Somewhere else, a planet could be nearing the final stages of its long life, slowly losing its atmosphere or drifting closer to its star with each passing orbit. These changes remind us that planets are not static objects frozen in place. They are part of an ongoing cosmic story that stretches across unimaginable spans of time. And yet, despite all these transformations, there is a remarkable sense of balance in the universe. Gravity acts as a quiet architect, guiding planets into stable orbits that can last for billions of years. When systems achieve this balance, they can remain stable long enough for complex processes to unfold on their worlds. On Earth, that long stability allowed oceans to form, continents to shift slowly across the surface, and life to emerge from the chemistry of the early seas. It is possible that similar stories may be unfolding right now on distant planets we have not yet fully explored. Somewhere in the galaxy, there could be worlds where oceans move beneath unfamiliar skies, where clouds drift across alien landscapes, or where simple life forms quietly evolve beneath dim starlight. Even if such places exist far beyond our reach, the knowledge that planets are so common makes the universe feel a little less empty. The stars above us are no longer just distant lights. They are centers of planetary systems, each with its own collection of worlds moving silently through space. Some of those worlds may be harsh and unwelcoming. Others might hold environments that are calm and stable for billions of years. The variety is vast, and our understanding of it continues to grow with every new observation. As telescopes become more powerful and new missions explore the sky, astronomers will continue adding to the map of planets scattered throughout the Milky Way. Each discovery will deepen our understanding of how planets form, evolve, and interact with their stars. Yet even as science continues its careful work, there is something beautifully simple about the image of planets quietly orbiting distant suns. No matter how strange their environments may be, they remain part of the same universal rhythm that shapes all celestial motion. Stars shine, planets turn, and gravity guides their paths through the darkness. If we could step far enough away from our own planet and look back at the Milky Way galaxy from a distant vantage point, the view would be quietly breathtaking. A vast spiral of stars stretching across space, glowing softly in the darkness. Within that spiral, hundreds of billions of stars move slowly along their galactic paths. And around many of those stars, countless planets circle patiently, each one following the quiet pull of gravity. When we first began discovering these distant worlds, it felt like opening the door to an entirely new chapter of astronomy. Suddenly, the universe was no longer defined only by stars, nebulae, and galaxies. It was also filled with planets, worlds with surfaces, atmospheres, clouds, storms, oceans, and mountains that we can only imagine from afar. Some of these planets are so hot that rock melts into glowing seas of lava. Others are so cold that even the atmosphere freezes and falls as snow. Some orbit tiny stars that glow softly for trillions of years. Others circle the remains of stars that exploded long ago. Yet despite all this variety, every planet shares one simple truth. Each one formed from the same basic ingredients that shaped our own world. Long ago, before planets existed, clouds of gas and dust drifted quietly through space. Gravity slowly gathered that material together, forming young stars surrounded by swirling disks of debris. Within those disks, grains of dust began to collide and stick together. Tiny particles became pebbles. Pebbles gathered into rocks. Rocks collided and merged into larger bodies until entire worlds began to take shape. This process happened again and again across the galaxy, building countless planetary systems over billions of years. Our own Earth formed in exactly this way about 4.5 billion years ago. At that time, the young solar system was a chaotic place filled with collisions and drifting debris. Gradually, the larger bodies cleared their orbits, leaving behind the familiar arrangement of planets we see today. Yet while our solar system settled into relative stability, the same process continued unfolding elsewhere in the galaxy. Even now, new stars are being born inside giant clouds of gas known as stellar nurseries. Within those glowing clouds, disks of material surround newborn stars, and within those disks, new planets are beginning to form. Somewhere right now, dust is gathering around a young star, quietly assembling a world that may someday become a rocky planet, a gas giant, or something stranger than we can yet imagine. It is comforting to realize that planet formation is not a rare or delicate process. It is a natural outcome of the way the universe works. Whenever a star forms, the leftover material around it has the potential to build planets. Given enough time, gravity patiently shapes that material into worlds that begin their long journeys around their stars. Over billions of years, those planets may develop atmospheres, oceans, or ice-covered landscapes. Some may remain barren and silent, Others might experience geological activity that reshapes their surfaces over time. And in rare cases, the conditions may become just right for life to appear. Even if life is uncommon, the sheer number of planets in the galaxy means the possibility cannot be ignored. There may be distant worlds where oceans move beneath alien skies, where unfamiliar weather patterns shape the landscape, or where living organisms slowly adapt to environments very different from our own. For now, those worlds remain far beyond our reach. Yet through science and patient observation, we have begun to glimpse the outlines of their existence. Each new discovery adds another quiet reminder that our universe is filled with places we have not yet explored. And somewhere among those countless planets, new stories are unfolding in the slow rhythm of cosmic time. As we continue this quiet reflection on the countless planets scattered throughout the galaxy, it becomes easier to see our own world in a slightly different way. For most of human history, Earth felt like the center of everything we knew. The ground beneath our feet, the sky above us, the oceans and continents that shaped our civilizations. All of it seemed uniquely ours. But the discoveries of modern astronomy have gently shifted that perspective. Earth is still special to us, of course. It is our home, the place where life has flourished for billions of years. Yet when we step back and consider the enormous number of planets now known to exist, our world becomes part of a much larger cosmic family. Somewhere across the galaxy there are rocky worlds not so different from Earth in size and composition. Some may orbit within comfortable distances from their stars, where temperatures allow liquid water to exist. Others may possess thick atmospheres that blanket their surfaces in clouds. A few might even have oceans stretching across their landscapes, reflecting the light of distant suns. Whether any of those worlds truly resemble Earth remains an open question. The distances involved make it difficult to observe them in great detail. Even our most advanced telescopes can only gather small hints about their atmospheres and orbits. Yet those hints are enough to tell us that planetary diversity is far greater than we once imagined. Some planets may be dominated by endless deserts of rock and dust. Others could be ocean worlds with no continents at all. There might be planets covered in global ice sheets, their surfaces locked beneath frozen crusts that hide deep internal oceans. And there may also be worlds where thick atmospheres create perpetual clouds, concealing whatever landscapes lie beneath. Each possibility adds another layer to the quiet wonder of planetary science. When astronomers search the sky for planets, they are not simply cataloging distant objects. They are gradually building a map of the environments that exist throughout the galaxy. This map helps us understand how planets form, how they evolve, and how different star systems shape the worlds that orbit them. Over time, this knowledge will likely continue to expand. Future telescopes may be able to directly image some nearby exoplanets, revealing faint glimmers of light reflected from their surfaces or clouds. Instruments may analyze the chemistry of their atmospheres with increasing precision, searching for combinations of gases that could hint at biological activity. These investigations will require patience and careful observation. The signals we search for are incredibly faint, often buried within the overwhelming brightness of the stars those planets orbit. Yet astronomers have shown again and again that even the faintest clues can reveal remarkable discoveries when studied with care. In many ways, the exploration of exoplanets resembles the early exploration of our own planet's oceans. For centuries, sailors crossed vast stretches of water with only rough maps and scattered observations to guide them. Over time, those maps grew more detailed as explorers charted new coastlines and islands. Today, astronomers are doing something similar on a cosmic scale. Instead of charting oceans, they are mapping the countless planetary systems that fill our galaxy. Each new discovery is like adding another island to a growing chart of the universe. And just as ancient explorers once gazed across the horizon wondering what lands might lie beyond it, we now look toward the stars with a similar sense of curiosity. The difference is that the horizon we face stretches across light years of space, filled with worlds we may never visit but can still learn to understand. As we continue to explore these distant planets through science and imagination, the universe feels a little larger, a little richer, and a little more full of quiet possibilities. And now, as our journey through these distant planetary systems slowly begins to settle, it helps to return to a quieter perspective. The universe we have been exploring tonight may sound vast and dramatic, filled with strange worlds of fire, ice, storms, and darkness. Yet the deeper truth is that most of the cosmos moves in a calm and patient rhythm. Planets orbit their stars not with sudden motion, but with gentle, steady paths that repeat over and over again. A planet may circle its star millions of times across its lifetime, each orbit following the same invisible curve through space. From far away, the movement would look almost still, like a slow dance unfolding over centuries. The star glows softly at the center, while its planets drift around it in silence, guided by gravity's quiet pull. Some of those planets may experience storms, shifting atmospheres, or changing climates, but their motion through space remains peaceful and steady. Even the dramatic events we discussed earlier, collisions, migrations, or planets drifting away into interstellar space, unfold over enormous stretches of time. In the universe, change is usually slow. Mountains may rise and fall on distant worlds over millions of years. Atmospheres may gradually thicken or thin as stars brighten or cool. Entire oceans might freeze or melt as planetary climates evolve. Yet through all of these transformations, the broader rhythm of the cosmos continues unchanged. Stars shine, planets orbit, and galaxies slowly rotate through the darkness. When we look up at the night sky from Earth, we are witnessing only a tiny moment in this immense story. The light from distant stars may have traveled for decades, centuries, or even thousands of years before reaching our eyes. During that time, the planets orbiting those stars have continued their silent journeys. Clouds may have drifted across alien skies. Winds may have shaped unfamiliar landscapes. Somewhere out there, a planet may be experiencing its own sunrise beneath a distant sun, while another world is settling into a quiet night beneath unfamiliar constellations. These places remain far beyond our reach for now, separated from us by distances so vast that even our fastest spacecraft could not cross them in a human lifetime. Yet, through the careful work of astronomy, we have already begun to learn their stories. By observing faint starlight and subtle movements across the sky, we have discovered that planets are not rare exceptions. They are natural companions to stars, forming wherever the right conditions allow gravity to gather dust and gas into new worlds. And once those worlds are born, they begin their long, quiet journeys through space. As your mind begins to relax and drift towards sleep, it can be comforting to imagine those countless planets continuing their steady orbits across the galaxy. Far away from Earth, beyond the reach of our oceans and continents, entire planetary systems move patiently through the darkness. Some may hold landscapes shaped by ancient geology. Others might carry deep oceans beneath thick layers of ice. A few may even possess skies filled with clouds drifting slowly across distant horizons. Whether silent and barren or rich with hidden activity, each of these worlds follows the same gentle laws of gravity that guide our own planet through space. Earth itself is part of that same quiet motion. At this very moment, our world is orbiting the sun at tremendous speed, yet the movement feels calm and stable beneath our feet. Day turns to night, night turns to day, and the cycle continues as it has for billions of years. The same cosmic forces that shape distant planets are quietly guiding our own journey through the universe. And somewhere beyond the stars, countless other worlds are moving through the same peaceful rhythm, orbit after orbit, year after year, beneath the endless silence of space. So as the night deepens and your thoughts grow softer, you can imagine the galaxy filled with these quiet travelers, planets circling their stars, drifting through the darkness, each one part of a vast and beautiful universe that continues to unfold slowly, gently, and endlessly above us.